Morning Science 10, Mr. Thompson here. We're looking at B2.1, forms of energy. Energy, having energy is having the ability to do work or cause an object to move. There are many different forms of energy. So let's start with chemical energy. That's what we call the potential energy stored in the chemical bonds between atoms in a compound. When the chemical bonds are broken or rearranged, energy is generally released in the form of heat or light. Here's some examples of chemical energy. The food you eat. Energy stored in a battery. How about a hot pack? Okay? Exothermic reactions which release heat. Endothermic reactions absorb heat. Two specific reactions we look at are hydrocarbon combustion, where you have propane reacting with oxygen, making carbon dioxide gas, water, vapor, and energy. And there's also cellular respiration. This is where glucose combines with oxygen to produce carbon dioxide gas, water vapor, and energy once again. Notice the idea of rearranging atoms that occurs when methane is combusted with oxygen to make water vapor and carbon dioxide gas. All right, let's look at electrical energy. So that's the energy of a moving charged particle, which is generally the electron. In an electric circuit, moving electrons carry or transfer energy to a motor or electric appliance. Okay? Moving electrons create a magnetic field, and a magnetic field can cause magnets and other wires to move. Be the basis of an electric motor. Kinetic energy of moving electrons converted to other forms of energy, okay? Such as, motion, heat, light. And it shows right here, electricity is the flow of electrons around a circuit. Let's look at nuclear energy and solar energy. So nuclear energy, that's the energy stored within the atom. Inside the atom, protons and neutrons are bonded together by the strong nuclear force. In a nuclear reaction, where the nucleus of atoms is broken apart, okay, it's called fission. A tremendous amount of energy is released. Okay, in the sun, smaller atoms, hydrogen, bond together in a nuclear reaction. We call it fusion. Okay, form a larger atom, helium. Again, a large amount of energy is released. And here's like the proton-proton chain occurring to create eventually helium. All right, motion and energy. Kinetic energy. Any object that's in motion has kinetic energy. Energy of motion is what kinetic energy is all about. Let's look at gravitational potential. Potential energy of an object due to its position, okay, and gravitational force. Gravitational potential energy comes from lifting an object to a certain height. The higher you lift an object, the more potential energy it will have. And mechanical energy, that's the sum of potential energy and kinetic energy of an object. Okay, but how about heat and energy? So as molecules are heated, they move faster. Thermodynamics, that's the study of the relationships between work, heat, and energy. Heat's the transfer of energy from a hot object to a cold object. Heat always moves. Okay? From hot objects to cold objects. The first law of thermodynamics. Okay, Joule's experiment. So, performed experiments trying to convert mechanical energy into heat energy. In any transfer of energy, some of the energy is lost to heat. This experiment was used to form the laws of thermodynamics. Okay? That essentially wraps up the first section. Let's move on to the next one.